Good morning students. Today we are going to deal with domain and range of trigonometric functions. Actually domain and range of the functions deal in second chapter, that is relation and function. But here we deal only the domain and range of trigonometric functions, not all functions. So as earlier discussion, when we take the axis, that is both the axes x and y, and when we draw a unit circle with center O, so actually this is 1 0, this is what, it is 1 and it is again 1, so B is, that is 0 1, it is y x dash x y dash. So if any point moves from this position to take point P, let coordinate of that point is xy, then OP will be 1, and when we draw perpendicular, then this is the perpendicular. If this is theta, then definitely this angle comes as theta. Now when P lies at point M, then what's about maximum value of x? Since this length OM is x and it is y, so if OP, that is P, lies at A, then maximum value of x is 1. If the same point P lies at point B, then maximum value of y is 1. Similarly, when here lie, then it is what? Minus 1, 0. And when that point lie here, then 0, minus 1. So, being a unit circle, it fixes the minimum value of the functions dealt here. Why we say that is? So, we start, that is domain and range of, that is circular functions or trigonometric functions. If I write a function, that is y is equal to fx, so the values x, that is gives domain, and total value of the fx or y, that is a part of range. It means what are the possible values of x, that is called the domain of the function, and total whole value of y for that function, that is called the range. So here two words are there and explanation like that. So I start, that is in unit circle. In unit circle, it is clear that x and y lie between what? That is minus 1 and 1. Minimum value is minus 1 and maximum value is 1. Lie between minus 1 and 1. From here, this figure we get the minimum value of, that is x minus 1, and that is, so we write, that is x is greater than or equal to minus 1, less than or equal to 1, and y is also takes the value starting from minus 1, and that is up to 1. Now in this triangle, when we discuss about the ratios, this angle comes as theta, this point is O, this point is P, this point is M, this angle is 90. Actually this 1 radii of the circle, this is y, this is x, so what is, that is cos theta. From this figure we get cos theta equal to x. Since x lies between minus 1 to 1, so it implies cos theta, that is as the values between minus 1 and 1. The same figure, if we write, that is sin theta equal to, that is y by 1, so it is equal to y. From here, y takes the values from minus 1 to 1, so therefore that is sin theta means sine of any angle, that is acute angle, is, that is greater than or equal to minus 1 1. This is about sine, this is about what? Cosine. Also at the same time, we know as cosec theta and sec theta are the reciprocals of cosec, means sine and cosine respectively. Therefore sec theta, or we write that is, cosec theta has the values or is an element r minus, that is minus 1. It means it do not take the values between minus 1 and 1. And sec theta also is element of r minus 1 to 1, and rest in case of tan and cot we are free, they can take any value. So for domain and range we may make the table, that is here this is the function, then it is domain and it is range. Okay, now if I write sine, so here domain is, that is r, it means all real numbers. Range is, it takes the values, here closed interval means what, including, and small bracket means excluding, and all real numbers between that. So it is minus 1 to 1. Then when I take next function cos, again it is r and it is minus 1 to 1. Then when I take tan, so tan means sin theta by cos theta. So in denominator there is cos theta. So that's why that never be equal to 0. So we write r minus cos theta is 0 for odd multiples of pi by 2. So I write 2n plus 1 pi by 2, n is any integer. It can have any value. Now cot, as you know, cot theta is cos by sine. Sine comes in denominator, so it is r minus n pi, n is any integer. Since sine of any angle which is integral multiple of pi is 0, so that to take not equal to 0 we are supposed to take this. Next, or now sec theta is here. What's about the domain? What type of values it take? It is 1 by cos. So again r minus 2n plus 1 into pi by 2, n is any integer, and it is r minus, that is minus 1 to 1. Last one is cosec, that is again r minus n pi, n is any integer, that is r minus. It means this is about the range. Sine of any angle, that is from minus 1 to 1, that is including. It never be less than minus 1 and more than 1. Same for cos. Tan and cot, it can take any value. For cosec and sec, take all real numbers, that is including 1 and more than 1, and that is including minus 1 and less than minus 1. This is about the domain and range. Now for getting the values of trigonometric ratios of the angles more than 90, since in class 10 you learn only up to 90, that we discussed in last video. That's why we are supposed to get or develop a rule. So here we discuss only two rules. Rule number 1, and it is again very easy not to remember. There is restriction for theta if theta is more than 0 but less than pi by 2. That is, theta is what type of angle? Acute angle. Okay. So rule number 1. Here I am going to divide it into two parts. One is, that is any integral multiples of pi plus minus theta, and any odd integral multiple of pi by 2 plus minus theta. So your rule number 1 is, that is for, that is n pi plus minus theta. Part 1 is, that is ratio remains same. Here ratio remains same. Okay, it means sine changes to sine, cos changes to cos, and tan changes to tan. Now second rule is, that is, angle remains same. If this side is theta, that we want to change, that side also theta. Third one is, sine. Which sign? Here we are using plus or minus. That is, depends upon the angle or the quadrant in which the angle lie. So here, first set the angle for respective quadrants. So this is about x-axis, y, x dash, y, it is 0 to pi, pi by 2, pi, 3 pi by 2. So first one is 0 to pi, that is only theta. So it is theta. Second quadrant, it is either pi by 2 plus theta or pi minus theta. It is also pi by 2 minus theta. It is pi plus theta. This is about third quadrant, or 3 pi by 2 minus theta. Actually it is 2 pi, first write 3 pi by 2, then plus theta, or 2 pi minus theta, it is fourth, and it is also 2 pi plus theta. This is about your quadrant distribution. So this is rule for example, if we want to get, that is sine, that is 3 pi plus 45 degree. So it is equal to, it lies in which quadrant? This is rule number 1. Ratio remains same, that is sine. Angle remains same, that is 45. Then what's about the sine, plus or minus? Since from here when we start, then it gets, that is 2 pi, again pi is here, and pi plus theta, it is pi plus theta, so actually it is minus, and simply we get, that is minus 1 by root 2. So your rule number 2 is, that is for odd integral multiples of pi by 2, that is 2n plus 1, that is pi by 2 plus minus theta. Again ratio changes as sine to cos and cos to sine, then tan to cot and cot to tan, sec to cosec and cosec to sec. Second one is, that is angle remains same. Then third one is, that is sine plus or minus, that is depends upon the quadrant in which the angle lie. It means if I want to get, that is tan, then pi by 2 plus theta. So rule number 1, ratio tan changes to cot. So write here cot. Rule number 1 applied. Okay. Angle remains same. So here angle is theta, acute angle. So here again theta. Now sine plus or minus. So pi by 2 plus theta. Pi by 2 plus theta in this quadrant. Here we write all, and it is sine and cos. It is tan and it is cos and sec. So in second quadrant, that is pi by 2 plus theta, tan is negative or positive? Negative. So that's why minus. This is about, and using these two rules we can find any value of known angle. Okay.